Okay, so since last two classes we have been discussing the multi-electronic systems and how do we account for the spectroscopic transitions happening in them. और उसी कॉन्टेक्स्ट में ये आपको हमने बताना शुरू किया that when you try to understand spectroscopic transitions you need to understand all the energy states that is possible. So you saw we had only Coulombic interaction initially that we could think of in electron. Then we discussed another interaction that was exchange interaction. Okay, and so you saw which was a simple p2 configuration then split up into 3, and now third type of interaction between the two electrons that can happen is what we have been discussing in the last class, already discussed in previous class at length. So it is the angular momentum of one electron, angular momentum of another electron, both start interacting, and that's what we know as coupling of the things. So they can, so it's just like a vector addition thing that you do. So two electrons with L is equal to 1 can add up like this. This is one possibility. They can, two electrons with L is equal to 1 can also have the vectors, angular momentum vectors due to orbital angular momentum vector. I am talking about, मैं किसकी बात कर रहा हूँ, orbital angular, purely अभी मैं सिर्फ और सिर्फ orbital angular momentum की बात कर रहा हूँ. I'm just talking about the orbital angular momentum which can be oriented like this, or third possibility is this one. Okay, so that's how you start thinking about in a three-dimensional space what is happening. Okay, and the resultant, so individually each of these electrons have certain orbital angular momentum, but the net resultant is 0, right? So that kind of situation can arise, and they are, so overall net angular momentum, total orbital angular momentum is 0. So these are three states, energy states that we can think of. ये तीन चीज़ें हम देख पाते हैं जब हम P2 configuration को again और बारीकी से analyze करते हैं. So now if you, it is like this, so this is the resultant vector. So resultant, this resultant is big one, okay, pointing in this direction, so sum of the two, and it will again have z component. Just a moment, let me just, अगर ये L is equal to 2 है तो इसका कितना, it will have orientation of this vector that we are talking about. This is so it will be having, हाँ, तो वो जो आपको ये ध्यान रखने, हाँ ये बहुत ध्यान रखना पड़ेगा कि हम क्या, what do we mean when we say, तो ये आपका रिजल्टेंट वेक्टर, दिस इज माय रिजल्टेंट दैट आई एम टॉकिंग अबाउट, ठीक है, जिसका कि हमारा जो not small l, we will write now the capital L into L plus 1 into H cross. ये मेरा रिजल्टेंट एंगुलर मोमेंटम है. इसका जो z कंपोनेंट होगा, the z component on, so this is my z axis, right? Z axis, and on this we will having the vector, the z component, which will be, oops, sorry, मेरा हाथ slip हो गया. So the z component along this will be ml h cross. So this is what we mean when we say ml is plus 2, it is having maximum of possible value along z. When we say for L is equal to 2, we can have plus 2 plus 1 0 -1 -2, राइट. सो इस तरह इतने सारे ओरिएंटेशन हो सकते हैं. तो you will imagine the things in the same manner. Just a moment. What happened? Okay, so this is what we will mean. So when if this is sorry, ये मैं animation अभी हटा रहा हूँ. ml plus 2, then the same thing if I am writing about ml plus 1, then the same vector will have less z component. So ये जो arrow मैंने बनाया था यहाँ पे, ये अब z axis पे थोड़ा और tilt होके यहाँ पे चला जाएगा, right? So this is will be ml plus 1 like this. The same vector, वही लंबा सा vector था, length वही है उसका under root l plus 1 h cross, but now it is having less, it is tilted towards the x and y axis, and z component is half of the initial when it was plus 2. ये इसका physical meaning है जो आपको समझना है. Okay, so always visualize this, that along z axis the component is now reduced. ml h cross है और ml is now, so z component is getting less and less when you are writing it like this. And when you are talking about 0, this whole thing is now pointing in this way again. So this is along no component along z when ml is 0, right? This is what we mean, the length of the arrow. So this is what you have to take care of when you draw the scale vector diagram. I gave you one question on that. For the simple one electron system in a multi-electronic system, this is how, again the things are similar. ml h cross is the component, l into l plus 1 h cross is the uh, magnitude of the angular momentum, orbital angular momentum that we are talking about. So ये आप अब समझ रहे हैं. अच्छा, अब एक और चीज रियलाइज करेंगे. m is equal to plus 1 वो तब भी होगा जब if suppose do you realize one more thing? If capital L is equal to 1, then also you will have the possible values of ml as plus 1, 0, minus 1. Now how will you draw the picture? What will be the difference? Suppose I ask you to draw a picture both when capital L is 2 and show the ml plus 1. Suppose the question is that draw the picture for L equal to ml plus 1, and the second one, compare it with when L is equal to 1 and ml is plus 1. Draw the two pictures, scale vector diagram. What will be the difference? अब आप अगर समझ रहे हैं तो क्या डिफर करेगा, क्या क्या अलग हो जाएगा? If I ask you to ये आप करके देखिएगा कल तक, ये होमवर्क है, कल कर लीजिएगा. ड्रॉ स्केल वेक्टर diagram okay, showing the angle between the two angle it makes, the vector makes, the total resultant vector makes with z axis. ठीक है, समझ रहे हैं? ml h cross, z component is same, but कैपिटल एल इज डिफरेंट, ठीक है। तो लेंथ ऑफ द टोटल एंगुलर मोमेंटम अलग अलग होगा। लेंथ ऑफ द, ये जो एरो हम बना रहे थे ना यहाँ पे, ये इसमें छोटा होगा जब एल इज इक्वल टू 1 ड्रॉ किया जाएगा, उसका आधा लेंथ का होगा। अगर आप टू द स्केल ड्राइंग कर रहे हैं, if you are defining your scale very well, then what in the case 1 and case 2, when you're trying to plot the scale vector diagram, the resultant vector, remember the capital L is small here, capital L is 1 here, smaller than the 2. So the this value magnitude will be less. So if you are drawing picture with pen and paper, you must show that it is the length of the vector is less. So you will assign a scale and then put it, show it of a lesser length, and then you, MLH cross is same, this value will particularly be same, but this value is different, right? और इसलिए एंगल भी अलग आएगा. So that is a fundamental thing that you need to understand. Okay, so this is what we have been discussing. So already this point was discussed, I think in the last class. We had how much you follow, I am worried about that part. कि कितना आप कर पा रहे, follow कर पा रहे हो, that I am not sure. So you, unless you show me whatever I give you as assignment, you do in every class, ठीक है। हर बार आपको ये नहीं करना पड़े कि देखो इसका नंबर जुड़ेगा तुम करो. Let me not force you with marks. Okay, so understand. So this is what we mean. समझ गए? रिजल्टेंट वेक्टर जो है इसमें बड़ा बन रहा है, ठीक है। इसमें जो रिजल्टेंट वेक्टर है छोटा होगा, है ना, और यहाँ तो जीरो होगा, समझ रहे? तो जब आपका इसका कंपोनेंट ड्रॉ करेंगे, इसका वाला जब कंपोनेंट ड्रॉ करेंगे MLH क्रॉस, तो ये ऐसे, और ये एंगल कुछ और होगा। फिर ये वाला जब ड्रॉ कर रहे हैं तो इसके लिए यू विल शो बिगर, मतलब समथिंग लाइक दिस फॉर दिस पर्टिकुलर थिंग, right? And then show theta zx. So that kind of picture should emerge in your mind when this kind of question flashes on the screen, right? ये concept ध्यान से देखिएगा. और so this is how I told you that you are given two electrons, p2 system, two electrons are there, L1 L2, मतलब दोनों का L वैल्यू 1 है. आप कैसे डिसाइड करेंगे? You will start the max, take these values L1 L1 plus L2, और इधर L1 माइनस L2, इन दोनों के बीच में ही सारी वैल्यूज होगी, बीच का सारा. सो 1 plus 1, 1 minus 1, so it becomes 2, this becomes 0, minus 1 and 0, so ये तीन ही होगा, ठीक है, like that. So this is how you proceed. This is what we know as, so find the two extreme, दो कोना पकड़ लीजिए, L1 plus L2, L1 minus L2, दो कोने आपने पकड़ लिए. You have defined your extremes, one corner another corner. Now it becomes easier to write what are the other values, possible values, combinations of L. Just go on deducting one from the highest one, L1 plus L2, deducting one at a time. So that's how you can find all the possible values of L. And yeah, that's how it becomes. So this is what we know as, when you write it like this, this is what we know as Claise-Gordon series for total orbital angular momentum, capital L. And then you have the values that we have just talked about, that magnitude, and then ML, what it tells you, it has, so how it is oriented in three-dimensional space, how many possible orientations, because this is again space quantization that we are talking about, not only the magnitude is quantized, even the orientation in three-dimensional space is also quantized. It cannot have any arbitrary orientation, and that is defined by this particular quantum number, which we have shown just now. Okay, so we just show it, already discussed in previous class, dps spdf. You see the capitals. Just for single electron we were using small letters, here we are using capital letters. Just that's the only difference. Once you have calculated L, it is easier to decide what to write. So that's one of the part of this thing. And then you have to take only the electron that is outside the closed shell. Closed shell का सारा जो filled shell है उसमें सब cancel out हो जाएगा, और जो बचेगा, so this is your sodium. So only an S term, only one electron is there, so sum of even L1 plus L2 will be 0 because it has, so it will be an S term, capital S term. Similarly, you should also think of yeah, you can also think of 2p1 3p1. this is this is one of the possible configurations. Okay, uh, to achieve a D state, you, this is one of the way which can be achieved. So this so think of, so we are trying to answer two things. uh, One is how do the yeah, difference in energy arises because of how they are we start thinking in classical terms. What, how the two electrons should circulate in around the nucleus such that capital L is 0? They will be moving in opposite directions, right? How they should move when we want L is capital L2? So both have L1 L2 is equal to 1, L2 is also 1, so they must be moving in the same direction, circulating in the same direction. And the picture that emerges is that when we are considering L is equal to 0, they are circulating opposite direction, and because of that they might meet somewhere. They, so in the first one, so because there's chances of meeting each other is more in case of L is equal to 0, the repulsion will increase, and that will, the energy will be more. Whereas in case of D term, it is they will be circulating in the same direction along different paths, and then the repulsion, they are not because they are not meeting each other, the repulsion will be less, and the energy of the system will be less. So this is why you have S term is in higher in energy than the D term. Okay, so this is a classical picture I told you. This is easier to visualize, but it has also been supported by quantum mechanical analysis, that is intense analysis. We are not going into that. So let's stick to the picture that we can easily imagine. When we are trying to lower the values of L, when we are just in case of L1 minus L2 plus 1 plus 1 minus 1 0, in that case we have to, the two electrons, apply the right hand thumb rule, you know, to have an angular momentum of two opposite signs. We need to have it circulating clockwise and anti-clockwise directions. But when you are having so this is your L is equal to L1 plus L2, which is 1 plus 1, and here L is equal to plus 1 minus 1, like that. So small l is this L is this. So if one is moving in this direction, the other one is moving in opposite direction. So this is how we are thinking, and the chances of meeting is more, they will repel each other. So That's one point why there is we always see this pattern whenever you are less than half filled, whenever you are considering less than half filled orbit subshells, this kind of situation will always be there. Okay, higher. So this is a contrasting thing in single electron system like hydrogen atom. We had what, L0 1 2, energy was increasing in this direction. But in a when two electrons system that we are seeing just now discussing this thing, then what we are realizing that if they are in p orbitals, p2 configuration, when we are discussing this, we find that when L is equal to 0 1 2, the energy is highest in this direction, right? So this kind of thing you can see it will happen. So smaller value of capital L will have larger energy, and that considerations comes from when you think of them orbiting in opposite direction to reduce the value of L. And if and so they come face to face, and then there is more repulsion. That is the way. So now how to write for D2 P3, D2 और P3 कैसे करेंगे again? So this class Gordon series is the key, holds the key for your thing, how to arrange them in that. So look at the L values, sum it up, and then you can make it like this. So L1 plus L2, L1 minus L2, maximum and minimum values you have to find, and then start writing. So 2 plus 2 maximum, L1 plus L2, 2 plus 2, and then this is the one end. The another end will be where I have L1 minus L2, that is 2 minus 2, so this is 0, and this one is 4. So now it becomes easy, 4 3 2 1 and 0. So these are the four possible, and so the energy state you can write accordingly. So this is how we make it is okay, like that. So that's when you are having more than two electrons, how do? You will always do two electrons at a time. ठीक है, तो पहले दो को सम करके रिजल्टेंट निकाल लीजिए, और उस रिजल्टेंट को फिर से तीसरे इलेक्ट्रॉन के साथ सम करते जाइए. So that's how. So look at, so you can define L prime here, first two electrons, and then get the maximum plus minimum. So 2 1 0 will come out to be the values. Now to each one of them you can think of add the third. L3 is equal to 1, so start adding that one. So take, so 2 1 0, take 2, then 2 plus L3. Okay, so in the same way, so 3, so when you are looking at this one, so 2 plus L3, then 1 plus 1, 1 plus L3, again 2, then 0 plus L3, which is 1. So whenever you are, so P3 configuration, when we are discussing P3 orbitals, then this is 1. So 2 plus 3 2 1, that's how we arrive at this thing. So you have three possible values of L when you are, so 3 2 1, then you can add, you can do the same thing for, sorry, ये कैसे, एक मिनट. So L prime plus L3, तो दिस इज द मैक्सिमम एंड लोएस्ट में क्या होगा, माइनस करना होगा एल प्राइम माइनस एल थ्री. सो दिस इज 3 एंड दिस इज 1. सो 3 to 1 आपको सिर्फ 2 वाला कंसिडर करने से आ गया. जब आप 2 वाला लेंगे, when you are considering L prime is equal to 2, then you are looking at L prime plus L3 1 and up to L prime minus L3. So 2 plus 1, 2 minus 1, like this. So in this manner you can consider. फिर इसी तरह से फिर 0 वाला भी आएगा, then 0 plus 1 only 2 values. So in this manner you can get whole set of values for corresponding to each of these L values. So finally you have L3, L2, L3, L1. So like this. So when L prime is 2, L prime is 1, L prime is 0. So 3, 2, 1, 2, 1, 0 and 1. Now you put it together, write all of them. So overall resultant L is 3, 2, 2 times, triple 3, 1, 3 times and 0. So this will give you 1F, 2D, 3P and 1S star. So pictorially looking at this P3 configuration, you can show the vector additions through pictures. So when all of them are resultant plus, this is your resultant, L is equal to 2. So first you add the 2 and then the third. Okay, resultant is less. So first we have taken the, in all cases it is how it is. So 2 electrons at a time. Okay, you get the resultant from the 2 electrons, then add the third one, and that's how we are showing it here pictorially. Okay, so 2 plus 1 you can have addition in 1 2 3, 3 2 1. And when you are talking about this thing, uh, L is 2, L is 1 0. So resultant L and the final. So this is what the meaning is, physical picture of how it's seen. So you can see that whenever we are showing L is equal to 1 or resultant state, okay, the resultants are changing. Resultant value is different. Resultant L is equal to 2. L is equal to 2 can result here also, that you can see sum. So this is how the vector sum works out. And when we are looking at D2 configuration, we had 2 plus 2 G state. So pictorially this is how it turns out to be. So this is when they are perfectly aligned, the angular momentum vectors. You have maximum value of angular momentum, resultant is high, and this is the same two vectors with L is equal to 2 now adding up in this manner at different angles. The resultant is small, and so on. It will be go on reducing like this. So F state. So when 4 3 L is equal to 3, L is equal to 2, like that. So this is what we mean when we say, and at one point they will both can be arranged like this. Resultant is 0 vectors. So it is in the decreasing order. You can see there are 5 states, G F D P S, and all these 5 states are shown here pictorially with decreasing value of L. Capital L is decreasing and finally becoming 0. Okay, so now if I ask you, you can do this by yourself. Find the terms that can arise from configuration of F1D1 and D3. You can do that. Yes, you should be able to do this. very easily. I'm leaving this an exercise for you, and that will be another set of assignment based on these things which you are solving. If you can solve, that will be good for you. कर सकते हो उसी तरह से जैसे बताया, जहाँ पे 3 इलेक्ट्रॉन हो गए, make us add the first two, then the third. Now the way we have shown that orbital angular momentum interact, and then there is which is represented through vector additions. In a similar way, the spin angular momentum of the two electrons, they will also interact, and that will also give you a resultant new spin angular momentum. So that also you should be able to see how it you should be able to visualize how that happens. So spin correlation, we have seen the parallel spins. We have earlier discussion of exchange energy has told us from that discussion on exchange, we know that parallel spins have lower energy as compared to the anti-parallel spins, and they actually differ in overall spin angular momentum. That's what we know. And when we are talking paired spin, that means two spin cancel out, and so cancellation leading to zero spin angular momentum. That's what we mean when we say they are paired, right? So that case also we had discussed in case of initially when we started multielectronic system. So when there are more than such two electrons, then you again have to take into account spin angular momentum, quantum number capital S, just the way we had capital L for the added terms of orbital angular momentum. In a similar way, we will have in capital S, okay, and it will be half integer, non-negative integer, half integer system. So that's how. So this will give you the magnitude of the momentum, and and then capital M with subscript S will give you the Z component. So again, we can, whenever we have to consider two electrons, we can start writing the quantum numbers S1 S2, addition of vector addition of the two, and then S1 minus S2 at the two extremes, and then if you see whether you can subtract -1 and get the intermediate values. So if there are only two electrons, you can have only two values, which is plus you can have half plus half or half minus half, that is 0. Okay, so this is how. ध्यान दीजिएगा, ये कई बार लोग ms प्लस ms वो करके दिखा देते हैं। ध्यान, ये एंगुलर मोमेंटम जो टोटल एंगुलर मोमेंटम है उसका वेक्टर सम करके आ रहा है, इसलिए दिस इज द करेक्ट रिप्रेजेंटेशन। ओके, जो L1 प्लस L2 कर रहे हैं, this is the correct representation, not you don't have to. Okay, Z component comes later in the picture, you don't have to jump to that. So when we are talking, we have already discussed, when we say spin paired, this is what we mean. There is one electron having uh, the Z component of the spin angular momentum vector pointing on the cone here in this direction. So on the back side of the cone, it is going in the that here. Okay, so that's what you can visualize. And the other electron is having just opposite, is having angular momentum opposite to it on the lower cone, and that's how. So there is only one possible arrangement when we say spin paired system, when they are anti-parallel. This have only, we can have, there is only one possible arrangement which can give you zero resultant. Zero resultant can be obtained in only one case. uh, so this kind of situation we say singlet. Singlet का मतलब क्या होता है समझते हो ना? सिंगल, एक ही है, डबलेट दो, ट्रिपलेट तीन, एक जैसा तीन तीन होगा अरेंजमेंट। सो सिंगलेट का मतलब एक ही पॉसिबल अरेंजमेंट है एंटी पैरेलल, whereas when you are talking about spins not being anti parallel, then you can have three possible arrangements. If the spins are parallel to each other, what we represent by this, then this is what we mean. Either they are put on the same cone, we can put them on two electrons having angular momentum on the same cone, right? The vector sum is the big one. So vector sum of the two is this resultant is big. The same magnitude remains whenever, so they can be also be placed on the lower cone, or they can, one of them can be on this cone, other one can be on this cone, yet the resultant value is same. So resultant angular momentum is shown, resultant is same in the three pictures. Three pictures that you see has same resultant, they have same, there's this angle between the two vectors is also same. Angle between the two vectors, and that's why we have the resultant is same, right? It remains unchanged, and that's why vector sum is same. So there are three possibilities, three, and that's why we call it triplet. ये जो अरेंजमेंट है इसको ट्रिपलेट इसीलिए कहा जाता है. Vector addition will be same, resultant is same, so that's what we are seeing here. They are what we see. So different. So the component along z axis changes, the ms individually you can so capital ms, the maximum value of, and in this case when capital M with substitute s, so z component is 0, z component of resultant is 0, here. It doesn't have, so this is shown by putting uh, two angular momentum vectors on each of the cone, making, so the angle is same. Realize this theta same in all these cases. The angle between the two cones, theta, theta, theta is same as the, so it has non-zero. In this case there will be non-zero total spin angular momentum. Okay, and there are three ways of doing so, achieving the resultant. This is the fundamental reason why you call it triplet. समझे? ये इसलिए नहीं कि वो ऐड करके 2s plus 1 ऐसा नहीं होता है, ठीक है? There are three possible ways in which the resultant angular momentum, spin angular momentum can be placed. So that also means that there are three possible ways in which you can place the two angular momenta on the cones, upper cone, lower cone. एक बार वो दोनों एक ही कोन पे है, दूसरी बार में वो दोनों दूसरी कोन पे, तीसरी बार में ठीक से फिर से वो लोअर वाले कोन पे है. अपर कोन, then they are distributed in upper and lower with the same angle, and third one. So that's why we call it triplet. समझे? The origin of the word why triplet and singlet. Triplet and singlet. Why we call them triplet? Why we call them singlet? Because the total spin angular momentum can have three different orientations, right? And you also now understand that when we are talking about something being anti-parallel case, it is slightly different. While parallel arrangement, so anti-parallel is very well, truly anti-parallel. But something which is not anti-parallel, we call it different from that. That is, we call it like this. Okay, so all three arrangements that we see here have same total spin angular momentum, and these are the three different ways in which the two spins can be arranged. Spin angular momentum can be arranged. They only have they on, this the only the orientation is different. They are pointing in different direction. The vector has the same length. The vectors have same length in each case. Resultant vector that we are talking about, resultant is having the same length, and they point in different directions. Okay, so this is the true meaning of something being पैरेलल स्पिन. जो पैरेलल कह रहे थे वैसा भी स्ट्रिक्टली पैरेलल नहीं होता है. It is only means that they have certain orientation, there's same angular momentum, and they will have a non-zero values of resultant of this spin vectors. ठीक है. एंड दिस इज व्हाट, इसी को हम पैरेलल स्पिन बोलते आ रहे थे. टू पैरेलल स्पिन का मतलब यही होता है. समझे? सो सिंगलेट वर्सेस ट्रिपलेट, ये सिंगलेट कहलाता है. ओनली वन अरेंजमेंट इज पॉसिबल, दैट्स व्हाई वी कॉल इट सिंगलेट. We call it triplet when unpaired spins. We call it triplet because there are three arrangements possible. Three ways in which you can arrange the spin vectors, spin angular momentum vector on the cone. Three possible ways. In all these pictures, the angles between them is same, so resultant is same. So that's why we call them. क्लियर? ये फंडामेंटल पॉइंट है, किसी बुक में नहीं मिलेगा जल्दी आसानी से. ध्यान दीजिएगा आप लोग. सिंगलेट, why we call it singlet, why we call this particular thing as triplet. ठीक है? And don't give me answers like whenever I ask you like 2s plus 1 होता है, 3 आता है इसलिए ट्रिपलेट कहते हैं. ऐसे नहीं. मल्टीप्लिसिटी 3 होता है. मल्टीप्लिसिटी का मतलब क्या होता है? व्हाट इज द मल्टीप्लिसिटी? There are multiple ways in which you can arrange the spins. How many multiples? 3. Here it is 3. In the bottom panel, upper panel, it is only 1. Multiplicity. What? When we talk about spin multiplicity, ask yourself question. This tells you how many ways, different ways, or rather ways the spins can be arranged. Vectors can be arranged. So precisely or you can say how many ways the resultant angular momentum can be placed in three-dimensional space. Spin vectors can be arranged, right? This is what we are asking ourselves the question. So there, when we say there's multiple ways, so this is, so you know how many different ways, we call it, we answer multiple ways, and the multiple ways here is 3, and that's why we are calling it triplet. When we are talking about the same thing, we are finding that this is 1, and that's why we are calling it singlet, right? समझ में आया? 3 तरीके हैं, एक तरीका है स्पिन्स को अरेंज करने का. दैट्स व्हाई वी कॉल इट सिंगलेट और ट्रिपलेट. बहुत इंपॉर्टेंट पॉइंट है. ओके, okay, so still spin angular momentum again. So when we are considering too many electrons are there are large number of electrons in the atom, you again have to do this summation of all the possible spin angular momenta, and then generate a Kleist Gordon series in a similar fashion that we have done for uh, orbital angular momentum, right? So you start with adding the two. So determine the two ends, s1 plus s2 and s1 minus s2. So this becomes my 2 ends. So this will always in a mod, only the magnitude has been taken. So if there are two electrons, we are considering half plus half, half plus half, and here it will be half minus half, 0. So this gives me 0, this gives me 1, right? 1 and 0, like that. So that's how we understand this thing. Okay. So similarly, when you have to add a third spin, so there are 3 electrons. If there are 3 electrons, then what you will follow the way I have told you in first case. First you have the two, add the spin vectors, quantum numbers for the first 2 electrons, and then the third one can be added to each one of them. So you will have uh, then total sum will be like 3 by 2 and half, like this. So we are taking the angular momentum vector and then submitting, not the z component. So value of s for the term, so again this this gives you s 2s plus 1 terms. So this 2s plus 1 tells you the number of ways the spin can be arranged. That's what we mean by spin multiplicity, the number of ways in which spin can be arranged. मतलब एंगुलर मोमेंटम वेक्टर को कितनी तरह से आप रख सकते हैं. That's what we mean, and that is always taken as a superscript. Superscript, triplet, singlet term. So whenever you have, so only when you are adding these spins, you always get either this kind of things, singlet, triplet, most of the time. So that's situation when s is 0, you get this. When capital S is 1, you get 3 triplets, and the 3 different thing. Remember, we have just what we have just seen. There are 3 different orientations. The 3 different ways are pictured here. The one way in which you can the anti-parallel spins is pictured here, right? So these are different ways you can put it, and then the ms value tells you the number of ways in which uh, the number of orientation that is possible in 3-dimensional space for the resultant vector, resultant spin angular momentum vector, right? So so paired spin we have considered. We now understand that closed shell, any closed shell, the spins will be paired, and s is 0, ms is also 0. So this kind of term, so any closed shell, simple 1s, the term symbol 1s will come. You are writing the superscript is your, जो ऊपर लिख रहे हो छोटा सा, वो स्पिन मल्टीप्लिसिटी को शो कर रहा है, ठीक है. For single electron it will be just s is equal to half, ms plus half minus the same thing. So that's how we are writing for sodium. If it is a doublet, then we will write 2p over that term, capital P with a superscript 2. There are 2 different ways. In this case, there will be, this means there are 2 different ways in which spins can be arranged, right? So we write it as 2. That will, so case to case basis you will have this kind of situation arising. So now we also understand that when we have parallel spins, which is so when they are not paired, this exchange energy that accounts for lowering of energy. So that is another way of stabilizing the thing. So if you consider now an arrangement 1 is to 2s1, suppose in case of helium atom this kind of state can arise, you will find that this one will have lower energy as compared to the 1 is 2 state. Uh, it can have lower energy. Parallel arrangement of spins, triplet state of 1 is 2 s1 is 1 is 2 2s1 is, so now we can say what we can say, it is triplet lies lower in energy than the singlet state. So in general we always have to think for any atoms or molecules the triplet state generally lies in lower in energy than the singlet state. Look at the word generally, not universally, but most of the time you will find in a triplet state you have lower energy. Um, so that is so maximum multiplicity is what we now know as Fund's rules of maximum multiplicity. For given configuration, the term of greatest multiplicity lies lowest in energy. Mm. So this interaction, the Coulombic interaction, is very strong, and you will find this happening. Triplet states difference between singlet and triplet state is relatively large. So, for example, when we compare for helium, in case of helium atom, the 1s1 2s1 state is lower in energy by an amount of zero point 0.8 electron volts. Huge difference. So, मतलब आप समझ रहे सिंगलेट वाला स्टेट हो गया 1s2, this is higher in energy, or this one is lower, and the lowering of energy is by this much amount in case of helium. So ground state जो helium का है 1s1 2s1 is not 1s2. So in a similar way, we can add the spins of any system, like when we are considering P2 or D2, the resultant spin angular momentum will turn out to be the same. Okay, when we have more than one, more than two, then P3, like P3 or D3 situation, then resultant is this or this. So this is what we can imagine and work out accordingly. So now this is the total angular momentum will be given by sum of both of what? Total spin angular momentum, total orbital angular momentum, and then summing up both the things together. So S1 and S2 gives you this capital S, adding up to give you this one. L1 and L2 add up to give you this, and then this J L plus S, capital S, is you are getting this J. Each one of them, individual S, the capital S, all can be shown on the cone. They will basically we are talking about angular momentum, and we know that angular momentum components, the x and y and z, follow the uncertainty principle, and so only one of them, the z component, is specified, rest two cannot be specified, and that's why we are always representing them on cone. This is the correct way of representing all the possible angular momenta in a multi-electronic system, right? Correct picture that emerges here. ओके, सो L1 L2 से ऐड होके एक कौन दूसरा कौन ऐड हुआ, दोनों ऐड होके L कैपिटल L मिल गया। छोटे छोटे दो कौन है, छोटे छोटे देखो सबसे क्यूट क्यूट कौन ये वाले छोटे वाले कौन है, ये दोनों ऐड हुए, ये उससे बड़ा कैपिटल S वाला मिला और सारे ऐड होके J, और टोटल एंगुलर मोमेंटम क्या होगा, J J प्लस वन, बस बाकी सारा कुछ वही रहेगा, H क्रॉस से मल्टीप्लाई कर दो। सो दिस इज योर टोटल एंगुलर मोमेंटम। एंगुलर टोटल एंगुलर मोमेंटम मतलब दो सोर्स ऑफ एंगुलर मोमेंटम था, स्पिन था, ऑर्बिटल मोशन था, दोनों को सम करके जब मल्टीपल इलेक्ट्रॉन्स होंगे तो ऐसे हम करेंगे। सो दिस इज व्हाट वी नो एज रसल सॉन्डर्स कपलिंग, and the number of values of that J can have is again Claes Gordon series, बहुत अच्छा रूल है। सो यू फिक्स द मैक्सिमम, द टू एंड्स मैक्सिमम एंड मिनिमम, बाकी बीच का -1 करके पहुंच जाओगे। ओके, so the magnitude is calculated by this, and specific value of J you have to write, and write subscript. So it is given as subscript towards the right of the length. So when J is equal to 2, it is a 3p term, then spin multiplicity is 3, L capital L is 1, so P in the middle we are writing, and then subscript on the right hand side of that representing the J, right? So the complete description of the state of the atom is given like this. Again, this is what we mean when we say so total angular momentum. Again, you will have Z component along the Z axis, this will be given by mj values, which will be given by mj is plus j 0 to minus j. So you can think of mj, so this value mj h cross tells you the Z component of the total angular momentum, summing up everything. So you understand now the cones, the different colors of the cones. Do you understand this blue cone? Blue cone is the L. This is total orbital angular momentum. This green one, capital S, total spin angular momentum. And then this one, this cone gives you total angular momentum for the system, for the atom, which is a sum of all this. So vector sum, one cone, other cone, vector sum, blue plus green gives you the purple, right? Blue plus green gives you the purple. This is the Z component is shown here, but this the arrow will be placed on this. So this is the complete thing. This is, look at the triangle that it is making, so to understand the sum that arise. So this is what we have, and we'll continue from here in the next class to discuss more on this. So there will be if S is less than L, capital L, there are 2s plus 1 values of J, 2s plus 1 values of J for given L. So the number of values of J is same as the multiplicity of the term. Remember this. So number of levels, multiplicity से आपको ये भी पता चल जाता है जब L का वैल्यू S से L is greater than S, equal to S, like that. Okay, so this we can see. Sodium atom excited state has L is equal to 1 and S half and a multiplicity of 2. The 2 so this you can just do it by yourself. Find the orbital energy states of sodium. Find the term symbols for the sodium in ground state and what are its possible excitations that you can try yourself. So what we have assumed here, what we are showing here, orbital angular momentum blue, green, total angular momentum as the purple. Total angular momentum is green and the blue. This is what we know as Russell-Saunders coupling. Okay, and there's also another thing, that JJ coupling. We are not going into that at this moment. We will try to fully focus on Russell-Saunders coupling. We will complete this. Okay, so here we are first summing up all the L, all the S, and then L plus S, capital S. JJ coupling will have different scheme. It is small l plus small s, so individual electrons L plus S, small l plus small s, and then we get small j and j small j coupled together. So that's JJ. JJ coupling is not we are not going to that. But what we it is reasonably, the Russell-Saunders system is accurate, reasonable for light atoms that we are discussing right now. Carbon, nitrogen, sodium, things like that. So this is, I am leaving you as an exercise. Write the term symbols for sodium, fluorine, and one of the excited state configuration of this carbon should be 1, should be 1. Write the term symbols for. Okay. So how we start with that we'll discuss later, and that's we'll do it tomorrow. Thank you, and yes.